Next coming up is Yangcheng. Yangcheng, can you hear us?
Yes, I can, you guys.
Okay, Yangcheng, I'm stoked to hear about Lepton and what you've been up to. And you have your screen share. Let's see. Okay.
Cool. Sounds great. Can you share? Can you see the slides?
Yes.
Cool.
Okay.
Yeah.
Yangcheng, take it away. I'll be back soon.
Thanks. It's great to meet you guys. And yeah, I'm not gonna be talking too much about the products and things like that, but I kind of feel that it's a good time to basically talk about, in general, LLMs and the kind of like common experiences and findings that we get from running LLMs and applications ourselves. So as a Chinese-centered group, like Origin, I kind of basically have heard quite a lot of interesting and sometimes scary stories about LLM being like AGI and super intelligence, things like that. And I kind of want to basically like demystify that a little bit and share my thought about what LLMs are. So we're all very familiar with all those kind of like typewriters, QWERTY and things like that, 26 keys plus some. When I was a kid, I actually did typing on Chinese typewriters, which is kind of weird because it has thousands of keys. You can't really basically keys and learn how to type with the typical typewriter kind of setup. This is what a Chinese typewriter looks like. And what it does is it actually kind of has all those keys as little foundries under the hood, and that handle goes around that board of a couple hundred keys and try to find the key and then type it on the scroll on the top. And you can see those keys as tokens and things like that. And one of the key advantages or one of the key challenges back in the days is actually how to type the things very quickly. So these are the little characters that are on the board. And the layout of that board actually allows you to type things like fast or slow and things like that. Sounds like the next token predictions. What we did back then was basically to go to the libraries and start counting what kind of characters or what kind of tokens happen after what kind of tokens before it, and then basically optimize the layout so that closer by tokens, or basically more frequently happening together tokens, are going to be grouped together. If you look at the middle bottom part, there's Zhongguo, which is China, and Zhongyang, which is Central, and Zhonghua, which is the Chinese ethnic group. They often come together, and so you basically put all those characters together close by, so that when you click one key, you're able to be moving to the next key very close by, so that you type fast. History tells us that by carefully rearranging those keys, the typing speed is actually increased by something like 90% or something like that. This is exactly what LLMs do today, as like a veteran in this AI world. And I kind of feel that when we are actually thinking about AI being like very intelligently doing AGI and general intelligence, we should always remember that large language models at the very bottom is actually just doing next token predictions, similar to all those kind of old typewriters do. The difference is that in the old days, we only look at the previous token, and today we're actually able to use GPUs and stuff like that to basically calculate like a really long context and using complex statistics and transformers to actually get a much more intelligent token predictions. And that kind of nature actually leads us to observe quite interesting LLM behaviors that could basically guide us what kind of things could be done and what kind of things couldn't be done. So LLMs can actually generate really reasonable responses, but it's still relatively silly, and hallucination is a very prominent thing. They work more slowly than the conventional ML models or other systems, and there isn't kind of like a standard way, despite an OpenAI standard actually gives things like very similar false sense of interchangeability. We kind of feel that basically today, when we're actually implementing LLMs into your actual workloads and things like that, a lot of things have to be taken very carefully. One is how to actually reduce hallucination. Two is actually how to fit your prompts and your kind of like expected runtime into the latency that your application needs. And then the third one is basically you actually want to incorporate a bunch of other knowledge, especially RAG and stuff like that, so that your LLMs can not only just extract information from the training that it learns from, but also the very fresh information such as search results, such as like your own enterprise data and stuff like that. One thing that we definitely observe is that and when the information is collected properly and when you actually use an AI properly, then building applications has been much easier than before. Lepton is an infrastructure company, and we basically help application companies to run AI algorithms, especially LLMs and all the other Gen AI algorithms, as easy as possible. But at some point, we wanted to basically learn how to build an app. So we built an app which is free. It's called Elmo Chat. And what it does is a very interesting and simple job. We see a lot of information today through Chrome, and there's that really long website, and we sometimes don't really want to spend 10 minutes going through the whole website or basically like watching a YouTube video and things like that. So we built this app, this kind of like plugin, sitting right next to your to your browser. Doesn't do anything when you don't need it to do anything, but if you actually want to like read a post that's really long and things like that, you can call Elmo. And then what it does is it basically it extracts the information from the web page, sends it to an LLM, and giving you the summaries, the opinions, and things like that. So imagine if you're doing like market research of a documentation, or you're watching a really long YouTube video like Jensen talking for an hour, you can actually get a very quick summary of the content, and then basically the key opinions and things like that, and key takeaways. For YouTube videos, I think we also have timelines and things like that. For the other things, such as like say keywords in there, you can actually use RAG. We call it insight. It goes to Google, search for the related results, and then gives you a summarization of what that is. And those kind of things actually gives you like reduces your research time of a web page or PDF and things like that from minutes down to something like a couple of seconds. Now, normally in the old days, it was like really difficult to actually, build an app like this. But for this app, we actually built it within like 2 days, and we're really nice. It was actually built by our head of front-end gentleman, which was the only front-end gentleman in the team. And he basically used the Wizard LM model that we actually have an API with, and we would like build it in a very short period. We also tried to do multilingual support and things like that. We're a very nice gentleman who's living in Tokyo. And we basically did a very quick interactions about some sort of keywords in the prompts, and then we actually enabled multilingual support by just translating this secret sauce, which is basically the gist of what Elmo does, that secret sauce from English to Japanese, and everything's like working really well. And we see quite a lot of similar application companies actually using prompt engineering and using fine-tuning to actually achieve very similar results and reducing their application development time from like months to days. And so through looking at those, we kind of summarized what kind of practical experience or practical guides we find very useful when building an app. Today, normally we kind of like start with available LLM services. OpenAI and Anthropic are really nice closed source ones, and normally we actually as an infra company we actually recommend people to actually start with the closed source models that are normally given best performances and see what the state of the art results could be. And with that, you can then basically prepare your knowledge and knowledge, and either put it in a knowledge base or do whatever kind of other conversion approaches to get the information to a format that LLMs are actually like understandable to LLMs. I kind of tend to basically not call it just RAG, but AG, or like augmented generation, right? The reason is because information is not only come from retrieval or search. It could come from, like the Elmo case, from the Chrome web page and parsing the web contents. It could actually come from like taking a screenshot of your screen and do OCRs and things like that, and then sending those information to the LLMs. Normally, then there are actually two paths that people take or the applications mandate. One is relatively qualitative, like say RAG or like summarizations or the conversations and things. And in those cases, human-in-the-loop kind of practice looks normally the best. And for Elmo, for example, we actually use ourselves as dog fooders and basically getting these kind of applications as quick as possible into people's hand and start basically doing sanity checks if it just makes sense, and then like tracking qualitative measures so that we know how to improve the prompts, the contents, and things like that. The other one that's kind of relatively less known today, but is actually super important, is actually the quantitative evaluations that in the old days the machine learning models used to do. So sentiment analysis, like imagine if you're actually doing customer support, you might want to see from conversation history if the user is actually happy or not. And those are classical quantitative results. And in those cases, I think we should basically just bring in the old school machine learning kind of knowledge and basically start doing like cross validations and other kind of standardized MLOps things. So make sure that we actually are getting these embedded into the rest of the logic as quick as possible. Normally, when we are actually kind of like following those approaches, data starts accumulating, and then you can basically, either like basically start building your own custom data, or basically like creating mode by going into vertical applications and improve the user experiences. And we see that people are starting to use more and more fine-tuned models, smaller models, when the application gets more clear and more verticalized and stuff like that. I think quick time constraint. I just want to like talk about like a bit of like high level kind of overviews. We kind of feel that over the last 1.5 years, AI infra has become the new pillar that a lot of applications need, in addition to the general web services and also the data services like Databricks and Snowflake. And what we are is we're a bunch of folks behind Cafe, PyTorch, Onyx, and cloud native platforms. And we basically help our clients to build from the APIs to begin with, and then eventually to dedicated modules by fine tuning deployments and all those ops and stuff like that. In the crazy days of all those like GPU shortage and things like that, we've done a lot of work in basically like making the infra easier for our users. And recently, we actually posted an H100 buying guide detailing everything that you need to know about H100 and all those like high performance GPU operations and things like that. So if you need LLM APIs, if you want to basically build your own models, and specifically if you need GPUs with a top-notch cloud-native platform, feel free to reach out to us, and we'll be more than happy to chat and help. With this, I think that's 10 minutes, and I want to stop here and see if there are any questions that you might have.
Nice. I don't think that we have any questions quite yet, Yangcheng, but
Right.
I will tell you this much: the Chinese typewriter.
Right.
This is brilliant. What a brilliant analogy.
Thanks.
I'm stunned by it. Do you have an idea of how they did it? Was it all just like was there like a person that just like statistically evaluated kind of the likely next word?
It was crazy. Yeah, it was basically the old days of data collection and data cleaning. You go to the library, you sit there, you basically like have a bigram count. Basically, like you start writing like basically like stroke 5, and then just like count. Right. There wasn't computers and things like that. Nowadays, you probably use Python, but back then it was just like all pencils.
Yeah, and I imagine it's just that maybe like the Latin typewriters never needed that sort of thing, simply because of like their more phonetic nature of the language. Is that the idea?
Exactly, yeah. So there was actually like a very nice talk, and my thought was actually inspired by that. If you go to YouTube and search for like the Chinese typewriter, there's a very nice gentleman talking about his research on comparative culture in some way, right? Basically, in the QWERTY kind of world, we never thought about the difficulty of like all those like not what type is what you get type model, right? And you actually need to basically like figure out alternative ways of the hardware and also the software. And he basically went on to talk about whatever like kind of like non-phonetic languages, how we actually solve these kind of like input-output interface problems. For me, the particular interesting part is it resonates so much with next prediction.
It's virtually one-to-one. Yangcheng, thank you very much. Please stick around the chat if folks have more questions.
Cool,
and we appreciate you and your time, and best of luck with Lepton.